Hello, good morning everyone. I am Vivek Kamboj and I welcome you all in the CNS seminar. So my seminar topic is differential cryptanalysis, but before diving into differential cryptanalysis, we have prerequisites of these topics. Let's dive into them. So number first topic is introduction. So it says a commonly used design for modern day block cipher is that of the iterative cipher. So previously what we do is we put a plain text and in the cipher and provide a key to the cipher, and it gives us cipher text to us. But in the modern day cipher, plaintext is gone through a series of ciphers. So, like in this, a plaintext go to a C1, which takes K1 and gives the input to C2, which takes a second key K2, and so on till Cn, which takes a key Kn and provides us the final cipher text. So modern block cipher requires a round function and a key schedules and these things. So the random key is the key that is required to generate the key K1 to Kn. Key scheduler construct the keys K1 to Kn using that key. Round function uses that key and the previous state and cipher and use it to make a new cipher. Let X be the plain text and Y be the cipher text. So it is shown in this. It is this is done in the sender part and this is done in the receiver part. So in the sender part, encryption is done. So we take the plain text and we put it in the W0, and here it is a rounding function that will generate a cipher, and each time it generate a cipher n times till we get the final cipher to transfer it to through the medium. Now in the receiver part, we have that cipher, we store it in WNR, and we will take the inverse of the rounding function that we have used that with the keys kn minus 1 to kn, that is the reverse order of this, and we will get the final plain text. So let's talk about substitution permutation network SPN. So it is a crypto system which has three positive integers LM and R and two permutations pi s and pi p. So in this SPN, we have a plain text and will generate the cipher text of length L into M, and the random key K will belongs to this set. Now it will use this K and it will produce these keys use and will encrypt the plain text using this algorithm. Now we will understand it with an example. Say now let's L and M and N R equals to 4. So this means there is 4. Those number of possibilities will be 2 to the power 4. That is 16. So our pious permutation will be like this and our pi p permutation will be like this. I will actually explain this later, but first of all we see the key scheduling. So in the key scheduling, let's say we have the random key k of 32 bit. Now we will have the keys k1 to k5 of 16 bit. So how we can generate from this k these all k's? It can be generated like we can use the first 16 bit for the first key, the from this to this for the our second key, and this for our third key, this to this is for our fourth key, and for the last 16 bit it is our fifth key. Now we will see how it is happening. So here our plain text is this, x, and here we have the k1 and we have w0 equals to x, our plain text. So we can see this diagram. We will encrypt this using this diagram. Like we use k1 and we have x2, we have generated u1, and then we have generated v1 and so on till we get the y, our final cipher text. So let's talk about the linear cryptanalysis. So we want to have the probability linear relationship between the subsets of the plain text bit and the subset data bits preceding the last round. That is, in the we have the cipher in iterative cipher, and we will provide the plain text, we provide key, and we take the cipher text. Now we will take the pair of the plain text and the cipher text, and we want to know if there is any behavior connection between them. This relation should be in the non-random fashion. So that's why it is called the plain text attack, because in this attack, attacker wants a lot of pair of the plain text and the cipher text pairs. If a attacker gets the output of more than half of the pairs, then it can say that this is most likely a sub key for a plain text and cipher text pairs, or we can say the system. So this is all about linear cryptanalysis. Now we come to our main topic, that is differential cryptanalysis. So what is the main difference between these two cryptanalysis? The main difference between the linear cryptanalysis and the differential cryptanalysis is that the differential cryptanalysis involves comparison of XOR of two inputs to the comparison to the XOR of the corresponding outputs. The differential attack is also known as the chosen plaintext attack. Why so? The reason is the attacker have to take the power to the system so that it can generate as many possible plaintext, and with the corresponding plaintext it can get the output from that and then compare with them. So in this we need two inputs, that is say x and x star, and we have to take the XOR of them. Say x dash is equals to x XOR x star. Now we will generate the decrypted cipher text of the x and x star. Say these are y and y star, from using all the possible keys. Then what will we do is we will take the XOR of these certain values, and we will increment the counter of the corresponding value. And if at the we expect the large one of the most likely a subkey, that is that key which has the maximum counter will be a subkey of that system. Now we go to the formal definition of this differential cryptanalysis. Let pi s be this function. Consider an ordered pair bitwise of the shift length m, say x and x star. We say that the input XOR of the S box S XOR x star and the output XOR pi s XOR pi s x star. For any x dash from this set, define the set the difference to consist of the ordered pair x and x star having the input XOR to the x dash. It is easy that any set delta x contains 2 key power m pairs. So if we know the value of delta x dash, then we can find the value of other input if we know the value of the one input. That is, if one input is x, then other input should be x XOR x star. Now, for each pair in delta x dash, we can compute the output XOR of the S box. Then we can tabulate the distribution of the output X box. There are 2 to the power m output XORs which are distributed among 2 to the power n possible values. This is known as differential trial, and if there exists such kind of thing, then it is possible for the attacker to attack this. Otherwise, ciphertext is secure under differential cryptanalysis. Now let's see in the notepad. So let's understand differential trial in some easy way. We know from our previous discussion that the iterative cipher is like that, where we provide the plain text and provide key one key like k1, it is k2 till kn, and to the different c1, c2 and cn ciphers connected in the series, and we will get the last cipher text. Now this is the same case only where we only consider the last cipher function. The other function, we made a function named pipe. We made a block of that function's named pipe. Now consider two inputs, say x and x star, such that x XOR x star is alpha. Now we put it in the function pi and generate the that y and y star. So y and y star should be beta. As we continue with the different x and x star, we will generate the different values of beta. If alpha and beta have high probability of these pair comes together with a high probability, the attacker can attack. Otherwise, the ciphertext is secure in the differential cryptanalysis. This is only known as the differential trial. Now, from our previous knowledge, we can say that the property of XOR, that if two numbers are XOR and the result is A, if one number is XORed by the result, then it will result in the second number. Similarly, if we take X as one of the plain text, then the other plain text should be X XOR alpha, where alpha should be the value of the XOR of the two plain text. Now we proceed further to how can we generate the key for this differential cryptanalysis. Now, as we have discussed, the x and x star are the two inputs and c1 and c2 are the outputs or the ciphertext of this system. We know that x XOR x star is alpha and y XOR y star is beta. So to find out the value of kn, we have to find the value of y in C1 and y star in C2. This means y should be f inverse of C1 with respect to the key kn, and y star should be f inverse of C2 with respect to the kn. So we can find the value of kn by using the different values of x, and can find the different values of kn by incrementing them, and the value or the key which counter is the maximum is the sub key for this system. Now we will consider with the following example. So here is the example of differential cryptanalysis. Here in this example, we are given the input XOR difference should be this. So For this difference, there can be multiple input pair such that like this and this. There can be many. For all of them, the XOR should be the same. Now we can, if y will corresponds to pi x and y star will correspond to the pi x star, then the difference in the output should be this. Now we can tabulate with for the particular x and x star, we can tabulate for the y star and for the difference of that. Now there can be multiple values of y dash corresponding to the 4-bit. That is, number of the value should be 16. But we will consider the one with the maximum counter, that is 8. So the y dash value should be the most probable value should be this 0010. In this example, only 5 out of 16 possible output XORs occur. This means that it is very non-uniform distribution. Like we see, out of the 16, only one, that is 0010, come 8 times, other come in very approximately less times. So we can compute all the possible input XORs as in the example 3. Now this ND will be the pair x comma x star such that their difference should be x dash and their outputs difference should be y dash. Now we can make a table from the input difference and the output difference, like here. Here we can see, for calculating the input XOR to the output XOR, we are not considering the rth round as I have discussed earlier. So the rth round key should not be considered in the upper encryption process. So this is how the differential cryptanalysis work. Here we will find out the propagation ratio, like rp is equal for a dash comma b dash with this formula, where 2 to the power m is the number of possible combination. So what is rp? rp is the probability of the, so such that the output XOR difference should be b dash if the input XOR difference should be a dash. This is what the differential trial is. So let us take an example from this. Say in the figure 5, this particular case is the differential trial for the SPN. Now, as I have discussed with this formula, we can calculate each step's probability from here to here, from here to here, and so on. Like this is shown here. Now, to find the probability of all the or full system, we should multiply it. This means that this is the probability of our decryption. Now, for the value x dash, we are getting v3 dash this. So, for any possible pair, we can, for any possible plain text, we can get the output with the probability this. This is what the differential cryptanalysis is. Now, how can we solve the thing, the ciphertext? This can be solved using the algorithm 3. We will discuss this in some minutes, but let us see the definition. Algorithm 3 presents the attack algorithm. The input and the output are similar to the linear attack, except the tau is the set of x, x star, y, y star, where x dash is fixed. Algorithm 3 makes use of a certain filtering operation, tuple x and x star, y and y star, for which the differential holds are often called right pair and allow us to determine the key bit. Here is a right pair has been formed. Y1 4 is equal dash y3 4 dash बराबर 0 0 0. This is an algorithm for the differential attack. In this algorithm, it is similar to what we have discussed a few minutes early. In this, we will make a table for the key and such that y and y dash should be the inverse of the last function, and the key which has the maximum counter will be our subkey. So a differential attack based on the differential trial. Here differential trial is necessary. Having proportional ratio equals to epsilon will often be successful if the number of the tuples x x star y y star, which we denote by t, is approximately c epsilon inverse for the small constant c. This means if this differential trial have a high probability, then only we can mount the differential attack. Otherwise, the ciphertext is secure under differential cryptanalysis. These are the references what we have used in making this seminar. Then these are the two books that I have considered in making this PPT and this seminar. Some parts or you can say definition are taken from the Wikipedia, and it is understood through the NPTEL course.